Assalamualaikum warahmatullahi wabarakatuh. Hello guys, this time I'm explain about material, condensation pass, coefficient of thermal expansion, and compressibility and hertz of fusion, vaporization, and sublimation. Before starting, I will introduce myself. My name is Betriana from Group 14 and I'm from Chemistry Program Study Department Science and Technology Raden Fatah, Palembang. Supporting lecturer Jauharuddin Luthfi Jabbar M.Si. Okay guys, let's go to material. Okay, now I'm explain the material, condensation phases. The physical property of a substance depends upon its physical stage. Water vapor, liquid water, and ice all have the same chemical property are considerably different. In general, covalent bonds determine molecular step, bond energy, chemical property, while intermolecular forces or non-covalent bonds influence the physical property of liquids and solids. The kinetic molecular theory of gas gives a reasonably accurate description of the behavior gas. A similar model can be applied to liquids, but it must take into account the non-zero volumes of particles and the presence of strong intermolecular attractive forces. The state of a substance depends on the balance between the kinetic energy of the individual particle or molecule or atom and the intermolecular forces. The kinetic energy keeps the molecule apart and moving around and is a function of the temperature and of the substance. The intermolecular forces are attractive forces that try to draw the particles together. As discussed previously, gases are very sensitive to temperature and pressure. However, these also affect liquids and solids too. Heating and cooling can change the kinetic energy of the particle in a substance, and so we can change the physical state of substance by heating or cooling it. Increasing the pressure on a substance forces the molecule closer together, which increases the strength of intermolecular forces. Okay, in this, I give a picture. This picture 1, picture 2, and picture 3. And in picture 1, and this as a liquid. Picture 2 in the gas stage, and picture 3 in solid form. The nature of the material based on its form. A. Solid. Biomaterial in the form of a substance has several properties as follows. 1. The location of the molecule is very close together. 2. Has a very attractive force between molecules so that the molecular motion is not free. 3. Has a limited molecular motion such as vibrate and spin in place. 4. The molecule is difficult to separate so that it keeps its shape fixed or unchanged. 5. The form of solids also unchanged when destroyed. 6. Solids are condensed phases. Okay, B. Liquid. The second material is liquid. The liquid substance has very unique characteristic, namely 1. The molecular motion is free and not bound. 2. The location of the molecule is relatively close when compared to gas, but it is farther away than the solid. 3. Liquid molecule can move plates, but it is not easy to increase the group because there is still attractive force. Okay, C. Gas substance. The property of gas substance include 1. The location of the molecule is very far apart. 2. The distance between molecules is very far when compared to this molecule. 3. Its constituent molecules move very freely. 4. There is almost no attraction between molecules. 5. Volume or shape are easy to change. 6. Can fill all the exciting rooms at this such. 7. Gas can be us. Example of gas substance are oxygen gas, argon gas. Okay, note, cooling a gas may change the state to a liquid. Cooling a liquid might change the state to a solid. Increasing the pressure on gas might change the state to a liquid. Increasing the pressure on a liquid might change the state to a solid. The true coefficient is related to the slope of the length versus temperature plot, while the main coefficient is governed by the slope of the curve between 2 points on the curve. Variation in CTF value can occur according to the definition as when A is constant over the temperature range, then A equally A bar. Finite element analysis or VEA software such as Nastran or M.Si software requires the B input, not a bar. Heating or cooling affects all the dimensions of a body of material, with a resultant change in volume. Volume change may be determined from delta V dividing V0 equally alpha V delta T, where delta V and V0 are the volume change and original volume, respectively, and AV represent the volume coefficient of thermal expansion. In many materials, the value of AV is anisotropic. That is, it depends on the crystallographic direction along which it is measured. For material in which the thermal expansion is isotropic, AV is approximately 3A1. Next, measurements. To determine the thermal expansion coefficient to physical quantities or displacement and temperature must be measured on a sample that is undergoing a thermal cycle. Three of the main techniques asked for CTM measurement are dilatometry, interferometry, and thermomechanical analysis. Okay, definition. Mass solid material expand when heating and contract when cooled. The change in length with temperature for a solid material can be expressed as LF minus L0 dividing L0 equally alpha 1 point TF minus T0. Delta L dividing L0 equally alpha 1 delta T. Alpha 1 equally 1 dividing L point dL dividing dt, where L0 and LF represents respectively the original and final lengths with the temperature change from T0 to TF. The parameter A1 CTE and has units of reciprocal temperature such as K or 10 point minus 6 dividing key conversion factor R. Okay, aluminium and aluminium alloys. The The dimensional change of aluminum and its alloys with a change of temperatures is roughly twice that of the various metals. The average CTF for commercially pure metal is 10 rank minus 6 Kelvin. Aluminum alloys are affected by the fusion of silicon and copper, which reduce expansion, and magnesium, which increase it. Its high expansion should be considered when aluminum is asked with other materials. Okay, dilatometry. Mechanical dilatometry technique are widely used. With this technique, a specimen is heightened in Fornage and displacement of the ends of the specimen are transmitted to a sensor by means of pass rod. Next, interferometry. With optical interference technique, displacement of the specimen and is measured in terms of the number of wavelengths of monochromatic light present significantly greater than with thermomechanical dilatometry. Next, thermomechanical analysis. Measurements are made with a thermomechanical analysis consisting of specimen holder and a probe that transmits change in length to a transducer that translates movements of the probe into an electrical signal. The apparatus also consists of a furnace for uniform heating, a temperature sensing element, calipers, and a means of recording results. Next, application consideration. With respect to temperature, the magnitude of the CTA increases with rising temperature. Thermal expansion of pure metals has been well characteristic up to their melting points, but data for engineering alloys at very high temperature may be limited. In general, CTA value for metals fall between those of ceramics or lower values and polymers or higher values. Okay, and this the last material. Compressibility and heads of fusion, vaporization, and sublimation. Fusion. When we had a crystalline solid, we increase the average energy of its atom, molecule, or ions, and the solid gets hotter. At some point, the energy becomes large enough to partially overcome the forces holding the molecule or ions of the solid in their phase position, and the solid begins the process of transitioning to the liquid stage, or melting. At this point, the temperature of the solid stops rising, despite the continual input of heat, and it remains constant until all of the solid is melted. Only after all of the solid has melted will continued heating increase the temperature of liquid. Okay, and this I give figure A, B, C, and D. In figure A, this beaker of ice has a temperature of means 120 Celsius. B, after 10 minutes, the ice has absorbed enough heat from the air to warm to 0 Celsius. A small amount has melted. And C, 30 minutes later, the ice has absorbed more hot, but its temperature is still 0 Celsius. The ice melts without changing its temperature. And only after all the ice has melted does the heat absorbed cause the temperature to increase to 22 derajat Celsius. Okay, in this figure. Next, if we stop heating during melting and place the mixture of solid and liquid in a perfectly insulted container so not heat can enter or escape, the solid and liquid phase remain in equilibrium. This is almost the situation with a mixture of ice and water in very good thermos bottle. Okay, and next, vaporization. Vaporization is the process that occurs when a chemical or element is converted from a liquid or a solid to a gas. When a liquid is converted to a gas, the process is called evaporation or boiling. When a solid is converted to a gas, that process is called sublimation. Evaporation occurs at temperature lower than the boiling point of the material. One important difference between evaporation and boiling is that boiling occurs below the surface in the bowl of the liquid and evaporation occurs at the surface of the liquid. Vaporization is an important step in the water cycle. Next, sublimation. Some solids can transition directly into the gas stage by passing the liquid stage via a process known as sublimation. At room temperature and standard pressure, a pitch of dry ice or solid CO2 sublimes, appearing to gradually disappear without ever forming any liquid. Snow and ice subdue at temperatures below the melting point of water, a slow process that might be accelerated by once and the radii atmosphere pressure at high altitudes. Okay, in figure 1. Figure 1 sublimation of solid iodine in the bottom of the products of a purple gas that subsequently deposits a solid iodine on the colder part of the tube above. Like vaporization, the process of sublimation requires an input of energy to overcome intermolecular attraction. The enthalpy of sublimation, delta sub, is the energy required to convert 1 mole of substance from the solid to the gas stage. For example, the sublimation of carbon dioxide is different by CO2 solid, so CO2 gas. Next, consider the extent to which intermolecular attraction must be overcome. Okay, finally, thank you. And I say sorry if I something wrong, and to Allah subhanahu wa ta'ala I forgiveness. Thank you guys. And see you in the next video. Wassalamualaikum warahmatullahi wabarakatuh.